Hey, you buddy, come here. Want to make some money? Yeah, I got a game for you. If you win, you get all my money. If you lose, I get to keep the money you give me. It just costs $5 to play. Want to play? Great. Thanks for the five. Now solve this problem, and you get all my money. If you don't get it right, I get to keep your five. Here's the quiz. With the five you gave me, I got $50 in my hand here. And it's all $5 bills or $10 bills. And I got a total of 7 bills. You tell me how many fives I got and how many tens I got, and you win it all. I didn't trust that guy, did you? And I wouldn't play a game with him. I don't think he'd be honest, but it is an interesting math problem. Let's see if we can solve it. The first question we have to ask ourselves is, what information do we have? And we're going to try to get this into like an algebraic expression. So let's start out with this. We know that there were a total of 7 bills, and that they were all either $5 bills or $10 bills. Well, let's turn this into algebra. To do that, we've got to have some variables. So we'll call x the number of $5 bills, and we'll call y the number of $10 bills. That's what we're trying to find out, how many fives and how many tens there were. So we'll call those, give those variable names, x and y. Now going back to that first statement, we know there's 7 bills, and they got to be fives or tens. So the number of $5 bills we've got plus the number of $10 bills we've got equals 7. Well, that's a start. We know one thing. Now, what else do we know? Well, we know that he had a total of $50. And we know that that $50 had to be some combination of $5 bills and $10 bills. Some number of $5 bills plus some number of $10 bills equals $50. Well, we could write that this way. $5 times the number of $5 bills plus $10 times the number of $10 bills equals $50. Well, that's pretty good. We've got two equations now that help us understand the situation in this problem. Well, there's a couple of ways we can solve this. The first way we're going to look at is with a graph. And there were a couple of bits of information we knew. We knew that the number of $5 bills plus the number of $10 bills equal a total of 7 bills. Well, I can rewrite that expression and put it into slope-intercept form, and it reads y equals minus x plus 7. Now, it's going to be easy to graph, because I know what the y-intercept is, so I got a point right there, and I know what the slope is, -1. So I've got 2 points. And with 2 points, I can draw a line, and that line represents those equations. There was another equation we had. We had $5 times the number of $5 bills plus $10 times the number of $10 bills equals $50. Well, I can also rewrite that expression and put it into slope-intercept form, and I get y equals minus 0.5x plus 5. I know what the y-intercept is, and I know what the slope is, so I can draw that line as well. Now, these two lines cross. They cross right there. They cross where x equals 4 and where y equals 3. And that's the solution to our problem. These two lines equate where x equals 4 and y equals 3. And we can double check that. 4 plus 3 equals 7. The number of $5 bills plus the number of $10 bills equals 7. And $5 times 4 bills plus $10 times 3 bills equals 20 plus 30 or $50. Well, we solved that with graphs, but I think it's going to be easier to solve this problem with algebra. What do we know in algebra? Well, we created two expressions. We knew that the number of $5 bills plus the number of $10 bills equaled a total of 7 bills. And we rewrote that expression in the slope-intercept form so we could graph it. Well, we'll also use it in slope-intercept form here. Y equals minus x plus 7. Let's write that down. We also knew that $5 times the number of $5 bills plus $10 times the number of $10 bills equaled $50. And I manipulated that expression so we got it in slope-intercept form, and we came up with y equals minus 0.5x plus 5. We'll write that down. Well, now we got two expressions over here, and they both tell us what y equals. Well, we know that y equals y, so whatever equals y has to equal the other thing that equals y. So we can rewrite that expression as minus x plus 7 equals minus 0.5x plus 5. Now I can use algebra to solve for x, and I end up with x equals 4. There are 4 $5 bills. And I can figure out how many $10 bills I've got real easily, because 4 $5 bills is 20, and I've got a total of $50, so 50 minus $20 is $30, which would be 3 $10 bills. Give this one a try. Hit your pause button, try the problem, and then hit your forward key to move on to the answer. Well, there's a lot of words in this problem, which makes it kind of confusing, and it's going to be an algebra solution. So the first thing I did was put in some variables. Let's call the people who attended the rock concert R. R equals the number of people who attended the rock concert. And we'll call C the number of people who attended the country concert. And we'll call M the number of months that go by. And it's still confusing to me, so let's see it. Let's circle the numbers and underline the question. And when we do that, it helps us focus in on the math portion of the problem, and will probably help us get to a way to put it together better. So I've circled the numbers, and I've underlined the question. There are 95 people at the country concert. There were 125 people at the rock concert. Now, I've got some information here. Can I put it into algebraic expressions? Well, sure. I know that the number of people attending the rock concert in subsequent months would be the 125 we originally had, less 5 people per month. So each month we're having 5 fewer people at the rock concert, and so the number at the rock concert would be the 125 minus 5 people times the number of months. Now I also know at the country concert the attendance is increasing. It was 95, but it's increasing by 4 per month. So C equals 95 plus 4M. Well, now I've got 2 equations. And I'm trying to solve for when the number of people at the rock concert equals the number of people at the country concert. That's the question. It says, how long will it be before the same number of people attend both concerts? When will R, the number attending the rock concert, equal C, the number attending the country concert? Well, I want R to equal C. So I want 125 minus 5M to equal 95 plus 4M. And if I set it up that way, I can solve for M. And when I do that, I get M equals 3.33. In 3 1/3 months, the number of people attending the rock concert and the number of people attending the country concert will be the same. Now you try this one. Hit the pause button, do the problem, and then hit the forward key to move on to the answer. Okay, there are 36 members of the team fan club. The number of boys is twice the number of girls. How many boys and how many girls are fan club members? Well, the first thing I did was throw some variables in here. Let's call the number of boys B and the number of girls G. And then I really think it's awfully helpful in word problems if we C is CC. So I circled the number, which is 36, and I also circled twice because twice is a number. It's 2 times. And then I underlined the question, how many boys and how many girls are fan club members? Well, first, what do we know? Well, we know that there are 36 members, and they're either girls or boys. So the number of boys plus the number of girls equals 36. We also know that there are twice as many boys as there are girls. So another way to say that is 2 times the number of girls equals the number of boys. Now, I've got 2 expressions here. I've got B equals 2G, and I've got B plus G equals 36. Well, if I know what B equals 2G, can't I just substitute for that B over there and rewrite this as 2G plus G equals 36? And if I do that, I can use algebra to solve for the number of girls, and I come up with 12 girls. So now we've answered a big part of the question, about half of it, how many girls were in the fan club. But we still need to know how many boys there are in the fan club. Well, we know how many girls there are, and we know that the girls, 2 times the girls equals the boys. We also know that the number of boys plus the number of girls equals 36, so we could substitute 12 in either of these places and solve for B. I used this one. I said the number of boys plus the number of girls equals 36. Boys plus 12 equals 36. Boys equals 24. The base of this rectangle is 3 times as long as the height. What is the length of the base? Well, they give us some additional information. They give us 2 bits of information. We know that the base is 3 times as long as the height. And we know that the perimeter equals 32 inches. So let's write those 2 equations. The base equals 3 times the height. We also know that the perimeter equals 32. And the perimeter would be this base plus this base, or 2b plus this height plus this height, or 2h. So 2b plus 2h equals 32. Now we've got 2 equations, and we can solve them and figure out what both b and h equals. We know that b equals 3h, so can I just substitute 3h for that b and then solve this equation? Yep, I sure can. I can say 2 times 3h, 2 times b, plus 2h equals 32. And then I solve for h, and I get h equals 4. So the height of this rectangle is 4, but what's the base? Well, we know that the base equals 3 times the height. So if I substitute h for 4 and put a 4 in there, the base equals 3 times 4, or 12. That's our lesson on writing systems of linear equations. Now it's time to test yourself. Go to www.mastermath.info and download the worksheet on writing systems of linear equations. After you solve those problems, go back to MasterMath and take the quiz on writing systems of linear equations. I hope you had a great time, and I hope you come back again real soon.